Hello. In this video we're going to discuss about a particular method that is very common in the game of cricket. We use it quite often. Not we, obviously. The people in the management use this particular method whenever there is an interruption in the game of cricket. Obviously that can be a rain. So in this video we're going to discuss about how this method actually works and what is this method actually and what is the mathematical theory behind this. So Duckworth-Lewis method was devised by two mathematicians, Frank Duckworth and Tony Lewis. We will not talk about the Duckworth-Lewis turn method because that particular method is not exposed to the common public. That particular method is not exposed to the common public, but the mathematical theory is more or less the same as the DL method. The DLS method is more or less the same as the Duckworth-Lewis method, but there are certain modifications. And so what is this Duckworth-Lewis method actually? The Duckworth-Lewis method is a method used in cricket in cases when the play is interrupted due to rain. So in this method, the target of the team batting in the second innings is modified and the revised target is prepared for the team, keeping certain facts like the total resources available for the both teams into consideration. Now, what do we mean by these resources? So these resources are actually calculated on the basis of the total wickets lost and the total overs remaining for the team to play. Moving on. So this is the formula by which we can calculate the revised target. So that's what's the mathematics behind this. So this is more or less the particular formula that is used in this method. That is, target equals to score times R2 over R1. Now what is this R2 and R1? So these are the resources of team 2. So R2 is the resources of team 2 and R2 is the resources of team 1. Now how are these resources calculated? Well, there is a particular table that is already predefined and we use that particular table in order to find the resources. So obviously that depends upon the total number of overs left for the team to play and the total number of wickets they have already lost. This is the particular table. Over here, if I zoom this a bit, you can see that we have two axes. On one axis, that is the horizontal axis, we can see it is written wickets lost. Over here, the numbers last from 0 to 9. And on the vertical axis, we have overs left. Obviously, this is for an ODI match. We can see it is up to 50 overs and the wickets last from 0 to 9. So this is the table that is predefined, and on the basis of this table we define the total resources for each team. Now let's take an example. Suppose there is a cricket match played between India and South Africa. So suppose South Africa is batting in the first innings and they have scored 166 with a loss of 4 wickets in their 22 overs. And suddenly rain started pouring down and obviously the game has to get stopped. Now the overs are reduced from 50 to 30. Now why are these overs reduced? Obviously the duration of the cricket game is a huge one, and keeping into consideration the time factor, these overs are actually reduced. These overs are reduced so that there is no such time factor. It might delay a lot, but we need to complete the game. So instead of lasting for the entire 50 overs, these overs are reduced a bit so that it gets completed in a particular duration of time. So suppose the total number of overs after the rain is reduced to 30 overs. And in their remaining 8 overs, South Africa manages to score 220 as their total score. Now, you might think that this is quite unfair for South Africa. So they were not having the mindset that they're going to play for 30 overs. They were with the mindset that they were going to play for the entire 50 overs. And if they had known about that, then they would obviously have played a bit aggressively and scored more runs. But here is the Duckworth-Lewis comes into handy. Over here, the target is manipulated. Obviously, India will get to play the 30 overs, but will get a modified target. So how is it so? So now we are going to calculate the resources available. Over here, we will first take into consideration the total resources available for South Africa once the rain started to pour. So over here, we can see that in 22 overs, South Africa had scored 166 with a loss of 4 wickets. So we will take into consideration the total number of overs left and the total wickets lost. So total wickets lost is equal to 4, and the total overs remaining is 50 minus 22, that is 28. So taking these data into consideration, from the table we can find out that this is actually 56.1%. So this 56.1% is calculated from the table. Not calculated, but this is actually taken from the table because this table is obviously predefined. Moving on. So after the rain started to pour down, after the game restarted, South Africa had only 8 overs in hand and they had obviously lost 4 wickets. So keeping that into consideration, that South Africa is remaining with 6 more wickets and 8 more overs, the resources available now for South Africa is 23.8%. Next we find the total loss in the resources. Obviously South Africa was having a particular resource in the beginning, but after the rain interruption, the resources got reduced. So the total loss in resources is 56.1% minus 23.8%, that is 32.3%. Now obviously if you want to find the total resources utilized by South Africa, that will obviously be 100 minus 32.3%, that is 67.7%. Now when India comes to bat in the second innings, India is left with 30 overs and 10 wickets in hand. So we can take these data into consideration and we can find the total resources available for India. So that is 75.1%. These all data are actually taken from this particular table. This is already predefined. This table is made by considering some of the historic matches in cricket history, and this table is predefined. We cannot manipulate this particular table. So we will simply substitute all the values in the formula that I have already defined. That is, target equals to score times R2 over R1. So over here, we will obviously not get an integer solution. We might get an integer solution, but it is less likely to get an integer solution. So over here, S times R2 over R1 will give us, not an integer, but whatever, it doesn't matter. Whatever we will get, we'll just add 1 with that and take the integral part of that particular form. Suppose we have 82.75, so we will take 82. So that's all. That's the theory behind calculating the target. So over here, it is 220 times 75.1 over 67.7 plus 1. So this will give us an approximate answer, that is 245. So the revised target for India is 245 in 30 overs. So you can see that this is more or less a fair judgment at this point, because India gets an increased total, because India will have the mindset that they're going to play for the 30 overs only and will not get the opportunity to play the 50 overs. But South Africa didn't have that till the 22 overs. It only got 8 overs when they had the mindset that they are going to play a shorter format. But India already had the mindset that they're going to play for the 30 overs, and they could obviously play much aggressively. Now, what's the mathematical theory behind this? So this theory I will not explain, but I will just talk about a bit about it, and I will just give an expression. Looks something like this. So this is an equation of exponential decay. Over here the W means the exponential decay constant, and the Z naught means the asymptotic average total in unlimited overs. So I will not talk much about this particular formula because it will take a bit long time. So I will just give the expression. So this is more or less the expression, and the theory, you can say this is more or less everything that is considered in the Duckworth-Lewis method. So there can be certain manipulations. The overs once the overs are reduced from 50 overs, at certain times it might also happen that the target is decreased. There can be certain examples for that, like the Afghanistan versus Sri Lanka in the group stage match of Cricket World Cup 2019. The overs were reduced, but the target for Afghanistan was also decreased. So there can be certain manipulations, but the theory behind this particular method remains the same. Now you might ask that why is this method used? Well, this was used after the 1992 Cricket World Cup semi-final match. The semi-final match was between England and South Africa, and at a particular time South Africa needed 22 runs in 13 balls to win the game. So you can obviously guess the gravity of the match, because it's a Cricket World Cup semi-final, and South Africa had required 22 runs in 13 balls. So probably it was achievable, but it was interrupted due to rain, and only after 12 minutes, the rain was there only for 12 minutes, and after 12 minutes South Africa was given a total of 21 runs, which was to be achieved in just one ball. So this is obviously injustice for South Africa. 22 runs in 13 balls was quite achievable, but 21 runs in one ball is obviously near to impossible. So after that, this method was devised, and this method more or less gives a fair judgment, and this is what made this particular method so famous. There was a mathematician, Stern, who also contributed to this particular method, and after that Duckworth-Lewis Stern method was used, and that particular method is not exposed to the public. That's a computer based one, and the theory is not known to the common public. It is programmed. So this is more or less everything in this video. Thanks for watching, and if you have liked my content, please like and subscribe to my channel.